Okay, so today we are doing lesson number 5 and 6. So it's a 2-day or 2-lesson kind of day. So lesson number 5 is solving inequalities in 2 variables using technology. And so all this is that it's showing us how to solve these in our calculator. So we've been doing this all along. We've been teaching you as we go. So for example, it shows you how to do this, how to get a solution set like this, and stuff like that. So we remember if we're doing these in our calculator that we want to be able to isolate the y so that we can graph it. So I'm going to add 12 to both sides. So 2x plus 3y is less than 12. Subtract 2x from both sides, giving us 3y is less than 12 minus 2x. Divide by 3, giving us y is less than 4 minus 2 over 3x. So if we graph this in our calculator, so let me pull mine up. We know that we can go 4 minus 2 divided by 3. So remember, if our coefficient is a rational number or fraction, that we want to have it in brackets here. And then also, because our solution is y is less than 4 minus 2 over 3x, we want to change this to a less than. So we'll remember that a less than is when the little wedge below is colored, and you can kind of remember because it's less than, so it's the lower one. And we graph it, and it looks like that. So this is something you'd want to put in your notes. So you can draw a picture of it. Sure. It'll look just as nice as this one. Okay, so then we find that everything below this line here is our solution. Okay, and so this is how we've been looking at these problems all along. So this is actually all that we're going to do in lesson number 5. There's no homework in it, so you can even say homework, omit all. Okay, because this is stuff we've been doing all along. So if we open up lesson number 6 now on page 535, we're solving quadratic inequalities in one variable by case analysis. So one variable means we're just going to have x's, and case analysis is actually what we're going to find out what that is in the lesson. So if we look at our graph here, this graph here, like this, is the graph of y is equal to x squared plus 2x minus 8. And so this section here and here, this is where y is greater than 0. Okay? So looking at our equation here, we say, okay, all these x's here make all of these y's here. And all of these y's that we have in red here are greater than 0. So we can actually say that our equation here, x squared plus 2x minus 8, this part here in the red is greater than 0. Okay? If we look at this part here, we can see that this is where y is less than 0. And so we know that all of these x's here in the middle make all of these y's negative or less than 0. So we say that for this section of the graph, x squared plus 2x minus 8 is less than 0. So where does this change happen between greater than 0 and less than 0? We can look at it and say, okay, well, right here at those x-intercepts, so at 2 and negative 4, this is where the change happens. So we know that when x is greater than 2, so all along here, that results in a y greater than 0. And when x is less than negative 4, so all along there, it results in a y that's greater than 0. Conversely, when x is less than 2 but greater than negative 4, so between the 2 points, we can see that we would get a y that's in the negative, that's less than 0. So we can write this in our notes. So when the graph is positive or greater than 0, we know that x is greater than 2 and or x is less than negative 4. Okay? And then the opposite, when the solution to the inequality is negative, we know that x is between negative 4 and 2. So x is greater than negative 4 and less than 2. So we can show our solution on a number line as well. So if we show the first one, the positive solution, we say, okay, well, x must be greater than 2. So that's this here. Actually, I'm going to put it in red so it matches our graph above. So the positive part is in red, like this, when x is greater than 2, and when x is less than negative 4. And because it's not a less than and equal to, we keep these as nice open circles. Okay? And this makes sense, because if we were to draw a picture of our graph right on top of this, we would see that, oh, this part here, where it's above 0, matches with this part right here and right here. Okay, so for our negative half of our graph, we can see that, okay, well, our solution set is when x is between negative 4 and 2, and we can see that on our graph here. So we know that this part here is our solution. Okay? And we can see that again, if we were to draw our graph on top, we would see that, oh, well, this part here is our negative part. And so that makes sense that it would be between negative 4 and 2. So if we flip the page, you're saying that they want us to use the graph of the function 12 plus 4x minus x squared to solve the inequality. So the first thing I'm going to do, and I mean, they give us a huge clue. They say use the graph of the function. So I'm going to graph this. So I go 12 plus 4x minus x squared. Then hit graph. I say, okay, well, I'm going to increase my windows a little bit. And I know from our equation that our y-intercept is at 12. So I'm going to try 15. I go y max is 15. I look at it and I say, okay, well, I can see my y-intercept, but I can't see the whole graph, so I'm going to increase it to 20. Awesome. So you'd want to draw a picture of this right next to the question. Okay. And so they're asking us to solve the inequality where the graph is greater than 0. So we can look at it and we can say, okay, well, we know that this is the part where it's greater than 0. And so all these y's here, the x's that cause that, is this part right in here. Okay? And so if this was a multiple choice question, or even they say use the graph, I'm going to use my graph and find those intercepts. So in multiple choice, make sure your y2 is set to 0. You can trace intersect. You definitely just want to use your calculator. So we know that one x-intercept is at -2. -2. And we can go and find the other one as well. So second trace intersect. Move all the way over. Enter, enter, enter. That's it. Perfect. My intersection is at 6. So right there. Okay. So on a multiple choice question, we would say, okay, we know that our solution is between -2 and 6. So x must be greater than or equal to -2 and less than or equal to 6. Okay? And we know that it's a greater than an equal to and a less than an equal to because we have an equal to sign here as well. Okay? You know that if this is a long answer question that we need to find this algebraically. So if we're doing that, we want to factor our equation just like we normally do. So we got to say, okay, what plus what is equal to 4? And what times what is equal to negative 12? Okay, so then we say, okay, well, what plus what is equal to 4 times what is negative 12? So that's positive 6 plus negative 2 is equal to 4, and positive 6 times negative 2 is equal to negative 12. So we go negative x squared plus 6x minus 2x plus 12. And we find that common factor between our first two terms. So we get a negative x, leaving us with x minus 6. Take a negative 2 out, leaving us with x minus 6. So our two factors are negative x minus 2 and x plus, or x minus 6. So we know that our y-intercepts are at negative 2 and positive 6. Okay? So then they ask us to show the solution on a number line. So we know that, okay, it's going to include negative 2. So we use a nice filled in circle and include include positive 6. And we know that it's going to be in between the two. So we can draw it like that. Okay? And then for part C, they ask us to state the solution to the inequality. But this time they want it so that it's less than 0. So we say, okay, well, that's going to be this part of the graph here and here. And we know that we find this with all of these x's here. So all of these x's here correspond to these negative y's. And so because we know that this happens at our x-intercepts, is where the change happens, we say, okay, when x is less than or equal to negative 2, or when x is greater than or equal to 6. Okay, so when x is less than negative 2 or greater than 6, we know that the result will be negative y's. Okay, so if you flip the page, we're going to start learning about case analysis. So I want you to take your pencil and cross this right out. Okay, and then just on top of it, write by case analysis. Okay, so when we're doing these by case analysis, we start them off the same way as always. I want you to graph them in your calculator first thing. Okay, so we go x squared minus x minus 20. Graph it. We'll get with our standard windows. And we know our y-intercept is negative 20 from this here. So I'm going to make my windows negative 25. There we go. And you want to draw a picture of this in your notes. Like this. Okay. And then we know, wait a second. Okay. That's not the graph we need. Let's try that again. So we go copy, screenshot, black and white, paste. There we go. So we want to find our x and y intercepts. So if this was a multiple choice question, I'd set my y2 to 0, and I'd find them just on my calculator. Enter, enter, enter. So we say, okay, it's negative 4 is this one. And we'd say, okay, second trace, intersect. And we go all the way over to the other one. Enter, enter, enter. And we say, okay, that's at 5. And so we know that because we're looking for something where it's less than or equal to 0, that that's going to be this part of the graph here. Okay? So we already know our solution. We know our solution happens when x is between negative 4 and 5. So x must be greater than or equal to -4, and less than or equal to 5. Okay, so this is our answer. If it was a multiple choice question, we'd be moving on to the next one already. Okay, so but this is a really good long answer question because there's a lot of good math here. So the first thing we would do algebraically is just the same. We want to find our x-intercepts. And so actually all we really need to do is find our two factors. So we get x minus 5 and x plus 4 must both be less than 0. And so we say, okay, we know that our two factors, when they multiply together, are less than 0. We can see that from here. So if we are multiplying two things together that result in a negative, because it's less than 0, so we can go negative, that means that one of our factors must be positive and one must be negative. So there's two cases. So say case 1, case 2. Okay. So like I said, because two things multiply together and make a negative, we know that one must be positive and one must be negative, resulting in a negative. And the other case is that our first one is negative and our second one is positive. Like that. Okay, so we write this by splitting up our factors. So we say, okay, in case 1, our first factor, so x minus 5, must be positive, so it's greater than or equal to 0. And our second factor, x plus 4, must be negative, so it's less than or equal to 0. In case 2, our first factor is negative, so x minus 5 must be less than or equal to 0. And our second factor is positive, so x plus 4 must be greater than or equal to 0. So with all four of these now, we just want to isolate x, so I'm going to add 5 to both of these. And I get x must be greater than or equal to 5. And I'm going to subtract 4 from both of these. So I get x must be less than or equal to -4. Okay. And then I get plus 5 from these ones. So I get x is less than or equal to 5. And here I get -4 and -4. So I get x must be greater than or equal to -4. So if we look at case 1, if we were to draw this on a number line now, we'd have -4 and 5. And we'd say, okay, our solution occurs when x is greater than 5 and when x is less than 4. And we'd look at this and say, oh, well, we will never have anything that is both greater than 5 and less than 4. So in case 1, there's no solution. Okay? In case 2, we want to do the same thing. So we set up our number line. We use filled in circles because they're greater than and less than and equal to. We'd say, okay, our solution occurs when x is less than 5, so like this. And it also occurs when x is greater than -4, so like this. So you can see we actually have an overlap. And this overlap portion is going to be our solution. So anywhere where we find an overlap in our cases, this is where the solution is. So we say, okay, well, x is greater than or equal to -4 and less than or equal to 5. Like this. Okay? And this matches with the solution we found in the very beginning. So life is good. So if you go to the next part of the page, this is actually all the notes for case analysis. And so what it says is that there's two separate situations. One where the inequality is greater than 0, so it's positive. And in the case that it's positive, we either know that both factors must be positive, resulting in a positive, or that both factors are negative, resulting in a positive. When the quadratic inequality is less than 0, or a negative, we know that the first factor is positive and the second factor is negative is one of our situations, one of our cases. And the second case is if the first one is negative and the second one is positive. Okay? So if we flip to the page, we'll do one more example together. So we can use case analysis to solve this. So just like with the last one, the first thing we're going to do is graph this in our graphing calculator, because we can find the solution before we even start, and then we'll always know whether or not we're right. So I'm going to go and give us some standard windows.